I want people to understand the scale of electrical vehicles we are talking about here. The energy sectors, automobile sectors, each of them is multi-trillion-dollar segments. My name is Liang. I'm an electrical engineer by training. I serve as the managing director for Stanford Bits and Watts Initiative, with a mission to digital transform the electrical power grid. I'm so excited to work on the climate tech map, which gives people a tangible technology roadmap, be able to reduce the emissions. I joined Stanford in 2019. Then I realized that I need to drive 40 miles each way to work. Then I replaced my big SUV with electrical vehicles for the reason of the gasoline cost, the EV carpooling, and also the auto drive capability. And at the same time, my research work aligned really well with my personal choice. And at that time, my first project is to help Stanford to launch the project called the EV50, with the goal that 50% of the passenger cars will be electrified by 2030. When we started the project, I realized we need more. So I made a very interesting decision to change my license plate to become EV100. That's a research goal, but it's also my personal commitment. The reason for the innovation in this area, a top three on my mind is the following. The first one is the climate impact is massive. So the transportation sector alone is one of the largest sectors to the greenhouse gas emissions. And the electrification of vehicles is the fastest way to be able to reduce the CO2 emission. And it's more than just the CO2 emissions, but also about air pollution, the NOx, and other benefits as well. The second is the sustainability benefits has to align with the economic benefits as well. So I'm thinking about electrification transportation can produce huge economic benefits to any regions, any countries, and or company as well. It's aligned a different spectrum of the industry, including the electricity, including the equipment, including the transportation sector, the AI, the service, and all of them. And the last but not least is we have, in the most of developed countries, United States, European countries, we have aging infrastructure issues. This kind of new load from EV gave us opportunity to be able to harden our infrastructure. There are many opportunities for innovation in the electrical vehicle areas. How we improve the battery technology in terms of the energy density, in terms of the safety, the cost, the charging speed, that's a tremendous opportunity. And the second one is we don't need gasoline, but we need the electron to charge the car. And how we build and utilize our charging infrastructure, where to charge, when to charge, how to charge will be very important. Just to give you an example, about 2 or 3 years ago, we published a Nature Energy paper. Many of you may not read the paper, but very likely you read the news. The headline for the news is California, you are charging the car at the wrong time. Because most of us like to go home, we plug in, and the charging will be kicked in during the midnight. But that time, we don't use the solar. And because solar not shining during nighttime, and the grid emission is still very high. So our key message to the community is we need more level 2 public accessible chargers, like the level 2 charging station that more than 100 of them in the Stanford campus. One of the moonshot idea is one charge, 1,000 miles EV. And this means like it's really a technology breakthrough regarding the energy density for the battery, at least 3, maybe 4 times higher than we have. Be able to maintain the same cost and maintain the same safety or even higher. By doing that, we don't need any charging stations between San Francisco and LA. I can do a round trip, only one charge at my house or somewhere. And this means more than just passenger vehicles. If we can do that, then we really unlock the opportunity in the heavy-duty EV space. And the second, I always dream about we don't need to charge our EVs. This can be like always-on EVs paired with car top solars with on-car generation, and could be forever nuclear, and may have wireless charging on the road, and the car will never stop. You will never worry about where to find the charging stations, where to find the gasoline stations. My first reaction for the opportunity space is huge. This is really the intersection between the energy sector and the automobile industry. If you're an electrical engineer, you will have opportunities. If you're a material science engineer, you will have opportunities. Even you are policy, but my advice, if you're interested in this area, is really think big and be practical. And you need to have big ideas, but these ideas need to be practical and be able to scale as well. I want people to understand the scale of electrical vehicles we are talking about here. The energy sectors, automobile sectors, each of them is multi-trillion-dollar segments. With AI and autonomous vehicles, most of the autonomous vehicles are electrical vehicles. This converge will lead us into tens of trillion dollars new segments. And these new segments also will be the first proving ground for the physical AI, which more pointing toward $100 trillion new economy.